In this video, I will guide you through an advanced tutorial on grid-connected PV system simulations. This video builds on my previous PVsyst videos and focus on more detailed system settings, loss analysis, both 3D and 2D shading, and interpreting simulation results. If you already have basic knowledge of PVsyst, this video will help you more towards more professional and accurate system design using updated tools and features. This video is ideal for engineers, designers, and consultants who works on utility scale or commercial PV projects. As I mentioned that we have going to be design a grid connected system, so we have going to be first on a grid connected option. In this option we have multiple sub variants, and we have number of parameters. The main parameters including orientation, system, and then detail losses, self consumption. Then we, if we have any storage, then we use it, otherwise we skip this option as well. And after that, the horizon, that is automatically once we have going to be select a metronome data, then it will be going to be automatically detected. And then the next is near shading, where we have going to be create both 2D and 3D shading analysis, the installations of both panels on building, rooftop, and on ground as well. So we have going to be first save our project name over there. This is advanced PVsyst tutorial. Okay, once you assign the name, after that you have clicked to on save button, and then you also mention the file name as well. Click it PVsyst tutorial. It's up to your case where you have going to be your name accordingly. After that you click save it. Now the name is saved, click on yes. As your project name is saved, then the next thing is you have going to be select the location where you have going to be simulate your project. Is for the site selection, you first go to Google Earth, as I already plot the uh, rooftop area and the on-ground solar installation area as well. The red polygon is my building rooftop installations, and while the blue polygon shows where we are going to install on-ground system. From here you have going to be select go to PVsyst, and you first select the location, click on it. Here you have going to be assign a new location, click new. After that you have going to be select the geographical coordinates of your area, click on geographical coordinates. Here the option you have going to be click you have going to put a manually, or you have going to be one by one. It depends on you. I'm going to be decimal degree, or you have going to be select whether the option you have easily be chosen for your system. I'm going to be select decimal degree. After that click OK. Then you have going to be first select latitude, control C, copy it, and then click on paste over there. And the second is latitude, you will copy the latitude over there, and then go to your PVsyst, put your longitude over there. The altitude of this area you have to be find over there. You will click go to there, and here the elevation is your altitude. From you move to cursor at the mid of your project area. After that you will see over there the elevation is shown over there. You have click you just move your cursor on the mid of your project boundary. After that it's 31 meters, so you go to your PVsyst, type 31. After that this time zone of my area is 5. It depends on your case. You have select your time zone and then get form. Okay, once you will click over there, you have going to be select your country as well, Pakistan, and the site name you will assign your site name for this. It's PVsyst tutorial. Okay, once you will save it, after that you will be import. We use the metronome endpoint zero data, click import. The data is as imported. After that you will click OK and then save it. The geographical file is set on your database. You will click OK and then yes and save it, and you will pop over there the PVsyst tutorial. The site geographical allocation is set it on your system. Then click on OK. Okay, here you will see that this site has been modified, and please save. After once you will be assigned the site, after that you will click save it. Now the first two steps, the project name and the Meteor file and the Meteor site, you will select it. After that the third option is that you have going to be set the parameters and orientation. First go to orientation pane. From here as for my site, I already calculated that the planned tilt is fitted or 25 is good for my site. Azimuth is I assumed 0. Okay, it depends on you. If you have moving the azimuth, depends on you. You will either select azimuth. It depends on the uh, facing of your panel, and your shed also matters. If your site is true south, then you will not use azimuth. Otherwise, if you the building or your site move towards any left, right, west or east direction, then you will calculate your azimuth accordingly. And I already they have a video on it how to select azimuth. You will go to my previous videos and check how to be going to be set azimuth. After that, once you have going to be set your orientation, as I already mentioned over there, if it depends on you, you are going to be fed the, if you assign any tracking tilted access, you will click on it and you will assign accordingly. Yeah, if you have different options, then you will select over there. In my case, I have just fixed tilt fill stick plane, so I will select fixed tilt, and then I have going to be defined its orientation, that is 25. After that, click OK. Your orientation is set over there. Okay, the second option is going to be assign your system. Click on system, as I is going to plan 30 megawatt. So I have put my numeric values 30,000 kilowatt, that is a 30 megawatt. After that, I'm going to be whether we have going to be select our the module from this area. If you have another module, then definitely you have going to be select your module accordingly. I'm going to plan a J solar module. Okay, and then I have going to be the top 450 or 550 WP modules are used for this specific um, system. I will select over there 545. It depends on your case whether you have going to be a different module. Sometimes the module is not available in the system, then you have going to be assign a pen file, and you will import a pen file over there, and then you have going to be select your module. As I already mentioned in previous videos how to going to import a pen file and OND file of inverters. You will if you have not idea about that, then you will go back those videos and you will see, and you will easily import the pen file and OND files in this system. And the second option is uh, inverter over there. You have going to select, it depends on inverters. I going to be sun grow inverter for this system. Okay, solar, try now. There is sun grow inverter. I'm going to be select sun grow inverter, and it depends on whether I am going to be plan 100 kilowatt panel for my system, not use UMPGs. Here you have going to be assign your system that complete the area nominal power STC is 30,000 kilowatt. So if you have going to be move it or set the series, it's between 6 and 20. I have automatically the system preferred 17. modules in series, and the number of strings is 3238. This is okay for my system. After that, I have the POM ratio is 1.44. That is okay for my showing since the system size. I will check if there is any issue. This overload loss is a rough evaluation based on these histograms, and help check this is always okay for my system. If there is any error, then definitely I have going to be change the module series or number of strings. After that, click close and then click OK. Your system is okay. Now you have going to be third parameter, that is detail losses. As we have going to be select that is constant 29 for my system. The ohmic losses, I have just click on the ohmic losses, loss of STC. We assume loss of STC for my system. And the third thing is module quality which means more lossing, that you have going to be just click on. Then the third is soil losses is per my area, it's I assuming 2%. It depends on your case whether if your area is an eroded area of the erosion lane over there, then definitely with the loss factor of soiling is increases. Other than if you have the coastal area, then definitely if you have in a rain tropical region, then definitely the soil losses is negligible. If you have, if your project site lies in such areas such as in a eroded lane or sandy area, then definitely the soil factor depends on your area, project area as well. So I am factor we are not included it auxiliary losses. I just assume it, and the edging we also check it on as per system. The unavailability we assume as 1%, and availability random set it, and then specular correction, that is automatically check on, and then click OK. Now if there is some system errors shown over there, you will go back. The inverter power is slightly undersized, so you have going to be number of inverters 100 kilowatt. For 30 kilowatt you just assign 30 inverters. All right, the 30 inverters. From here you will going to be select inverter accordingly. If I'm going to plan uh, 30 megawatt, then I have preferred the 2000 kilowatt inverter for my system. I have going to be just select 13 or 15 inverters are enough for my system. Then the pop-up error is premium Roche is 1. So you one thing you have noted that the dual polynomial ratio must be under 1, not be exceeding 1. So once you have going to be design your system, you will must check the polynomial ratio, that it must be 1 also. Okay, now click on OK. Detail losses is also be identified now. The third thing is the horizon is automatically as per metronome. I have selected the horizon of the sun is automatically selected. Whether if you have your mass data, then definitely you have going to be manually input this horizon. Otherwise you will use the automatically selected metronome 8.0 or 8.2 data for your system. Now the third thing is near shading analysis. Now for this you have just going to be click near shading. Here first you check what is active area you use for your 30 megawatt system. The active area you mentioned over there, that is 142260 meter square area you have going to be required. The field tilt, the module tilt is 25 degree, and we have going to be using 0 azimuth as per our system. Now you have going to be click the construction perspective. From over there we have going to be first select the imagery for my system. As I mentioned, you have going to design your system on that specific imagery. You will go to Google Earth. This is your imagery area. You just save from the picture over there. Okay, save image. If you need any HD area, HD images, you will the maximum and not need further titles and other options for my specific imagery. You will mark it center. After that you will save your image. Okay, have just going to be F. I'm going to save in F. That is PVsyst tutorial. Save your image. Once image is saved, you will go back to your PVsyst. All right, you will save over there. Save your image. Now get back to your PVsyst. Here you will file and import your shading scene. You will import your image, grown image. All right, go to where you have, this is the image as we selected. Now you have going to, once you import the image over there, you must have to be scale your image first. To scale your image, you will use, see here, that is your x1 point and x2 point. Okay, image base width and the image x1 and x2 from select over there. You will just go to your Google Earth. From here you just any one spot as you select it. As I measure the total area from here, meters, click here, calculate your area. There is, the length is 308 meters. Okay, it's 308, or assume it 309. Okay, come back. You will put the first point. This is your first point and this is your second point. Now you put 309. The distance is 309. Apply it. Now your image is scaled. Okay, your image is scaled now. Now you have to install your shading scene on this imagery. Okay, as I previously mentioned, here is I have once a building area, building object as well. I have object, select the object. The red area, as I previously mentioned, this is the building area where we have going to be install the solar panel on rooftop, while the other blue area shows where we have going to be install a fixed tilt on ground PV shadings. From here we have going to be select building area. The building area is a two sided house where we have the width. You have to be calculate the width over there. It depends on you. You will be calculate the width from your uh, PVsyst, or you have going to be from your Google. It depends on you. Okay, the first thing is that the length is 54, 55 is its width, and its 250 is around its width, length. Okay, then select the width and its length. The width is its 55. It's not, it's 250, and the length is 55. Same, the height we assume it as a 10 meter. It depends on your case whether you have going to be install your building shape accordingly. Now place the object here. The building shows where we have going to be modified. You will move forward there. This is your building. Okay, you have to be rotate it. You will select your building and move accordingly as per your image. The building size is bit less from over there, it's 245, then you will be clicked it's 52, then place the object. It's still this. You will go to setting and you will be change your size accordingly. Okay, now you will check it and close it. Okay, this is your building as you seen over there. This is your building and this is your PV area. Now you have going to select a shading table from your system. You will assign accordingly. As I previously mentioned, we have using at least 7 meter pitch for our system for shading to shading, and we have use the panel as it depends on your case. I'm going to prefer landscape. Are you going to be use portrait? It depends on you. Okay, I think we have using portrait most of the time, but it depends on your case. I will increase the number of modules in length, and also change the we have just two modules on y-axis, and x-axis we it depends on your case. You have going to be assigned accordingly, then close it. You will see the panels. Okay, I have going to install panels from this area. You will assign pitch accordingly. The building height, you will if you install these on your building, then definitely you will change its height z factor as well. Our building height is 10 meters, then we have going to be 10.5. Then we will install on our building. Okay, you will see we have installed first on our building. We have going to be increase the number of sheds. I think 5 is okay for my building. Okay, you will check accordingly. This is my building installation. Just move it and you will copy paste, or you have going to be not assign one by one length. Okay, once you will done it, it will take time. Once I will install all the panels, and I will again resume my video. Now I'm going to pause to install all the sheds on ground. As you seen that I have installed all number of sheds on the building. Now we have going to be installed on ground. As I previously mentioned, on ground we not use z factor, we use it 0. We install it on ground. Okay, from here I have to increase my number of sheds. It's up to 16, and number of sheds it's around 80 for my case. It depends on your case. These are less, so I have to increase my number of sheds as well. I am going it's to 50, while in x-axis I have to increase up to 100. Now see what we seen on ground. Okay, that's perfect for me. Install accordingly, and one by one, as I previously mentioned in as during installation on rooftop, you will use the same steps over there. Once I've installed all sheds on ground, I will again resume my video. I'm going to pause to just install the sheds on ground. As you've seen that I install complete shadings on ground. Now we are going to render, and you will see the 3D look. Okay, they are installed on building as well and on ground installations as well. Now close it, then click yes. The shading factor table has not computed, and then click on click table. You see the shading factor table is computed over there, and it's a great installations that the shading factor of our diffuse is below 0.1, and then you're going to be click back, okay, and then save it. Your niche near shading is always done. If you have any other energy management or any economic options, you have going to be fit according to your system, or any self consumption if you are used, it depends on always your case. If you have any self consumption or any installations of any gen sets or any other options, you will accordingly for storage as well, you have to assign your storage accordingly, okay. The next thing is module layout. If you have any further, you have click module layout as well. Now right now our system is ready to simulation. We have going to be just click run simulation. Yeah, that's great. The system is run out and there is no any such sort of error. We have just click to report to see the report over there. They're generating report just for a minute. Now you will see your report. Okay, this is your system array characteristics, the array losses, as I we previously mentioned. This is what actually our near shading seen on this image. It depends on you. If you are going to be export any other image from the PVsyst, you can also export the image as well. Here is the losses diagram. We just check the minimal ratio, it is the 76.17%, that the performance ratio. Now you will come back to the system losses. You will see in the system losses over there, okay. This is your complete simulations. We will done it. If you have still any other variant, you are going to be create any further other variant, you will click over there for add a new variant, and you will be easily have to create a new variant as well. Now this system is done. We have going to be save project for future purpose. You will save it. The simulation is always done and saved. Then you have used accordingly, okay. I hope you enjoy this video. If you have further any queries, please put your draw your comments, leave your comments and your queries on comment section. I will back and we are going to answer your all related queries and more and other related videos. You will go to the visit this channel, and I also created a detailed playlist for the PVsyst course from beginner to advanced level. Thank you so much for watching this video. Take care. Bye.